So even before the hints, the first thing you probably would have tried, like what Michael did. Michael, what did you find out?
If you do the sine thing, there's always at least one variable in each one.
Yeah. So what happens when we do the sine law, try the sine law, so A over sine of A, B over sine of B, C equals C over sine of C, we see that we don't get a magic ratio there. In other words, a ratio where we both know both the numerator and the denominator. So what's happening is that when you get a situation where you get a triangle where you know both sides, two sides, and the angle in between, that's what happens, right? Because the opposite side to here, that's what we don't know, and then the opposite side of the lengths, we don't know the angles. So this is where we're kind of stuck, okay? Otherwise, the sine law is awesome because it's pretty easy to use. So this is where I gave the hint of, again, just drawing straight line down from one of our vertices. We got two right angle triangles, and we're going to split into two. So on one side, we're going to have the label base is x, right? So what makes the other side with the green is 75 minus x. Yes, Christian.
Oh, 75 minus x? I thought it was times x.
Sorry, it's minus x. If that wasn't clear. 75 minus x. Okay? Good? 75 minus x? Right? So that little trick that we used a couple of times now. So now what I'm going to do is I want to focus on the red triangle. I want to try to draw some properties that we see from this red triangle. Can I turn off all the lights? Is that good for everyone? What can we see about the red triangle, Michael?
Well, there's like for this one is the 60. Like if you did
Sine.
like ABC again, but with just a smaller triangle,
Right?
you can do 60 over sin 90 or sine 90.
60 over
See where the side length there's 60 on the triangle.
here?
Yeah, and then let's say B is the 90-degree angle.
Right.
You can do like the sine law, so then you got your full thing.
Well, we don't want to do anything with a 90-degree angle because you can't do sine and cosine. Well, you can, but not with the right angle triangles. Right. Christian?
Okay, so using sine, figure out what the line in the middle is.
Okay, so let's label this line in the middle. Let's call it H. Okay,
and then once you figure out what H is, you can figure out what X is.
Okay, so let's start from the beginning. What are we doing?
Okay, so we do sine 64 equals H over 60.
Okay, good. That's one thing. What I'm going to try to do is I'm going to try to abstract H. Not really deal with H concretely. Let's deal with X.
Okay, but like once you figure out H, you can figure out X. Oh, you just figure out X right away.
We could, you know what? I'm going to write that down. So we got sine of 64 is equal to H over 60. So we got H is equal to 60 over sine 64. Okay, so that's one thing that we could have. Okay, so does everybody see how we sort of got for H?
Well, why?
Sorry?
Wouldn't it just be 60 times sine 64?
Oh, sorry. Miscalculated there. So H is equal to 60 times sine of 64. Okay, can we do something similar with X?
Yeah.
What can we do with X at 64?
Can use
yeah, so we can use the cos, right? So here we can have cos of 64 is equal to X over 60, where X is equal to 60 times the cos of 64. Okay, write this down as we go along so that you're seeing the connections that we're making. Plus, the handwriting looks awful. That's what you did? Good. So we have sort of two things here. right? H is equal to 60 times the sine of 64, and x is equal to 60 times the cos of 64. There's one other relationship that we can kind of see in here, in the red triangle. Not angle C. Think back to maybe your grade 8 or 9 days. Not anything to do with angles. What relationship do we see with the red triangle in terms of the side lengths? Anything else to see with that red triangle? Yeah, Pythagorean theorem. Right? So how can we apply the Pythagorean theorem on the red triangle?
X squared plus H squared equals 60.
X squared plus H squared is equal to what?
60 or 60.
Not quite.
Squared.
60 squared. Right? So that's what we have on the left side. So not bad. We got 3 properties. What about on the green side? What can we say about the green triangle? Well, do we know any angle on that one other than the 90 degrees? No. So we can't even use our trig ratios. What's the only thing that we sort of know about this then?
H.
H, and what's what?
Oh, 75x.
75 minus
Minus
x. But what about them?
What?
What do we know about the? What can we say about the triangle in green? Triangle on the right.
Triangle.
That we know that x, like, b is 75 minus x.
Well, we know this length, yes, is 75 minus x. But in terms of a characteristic of the entire triangle, what can we see from there? What can we sort of use? Well, same thing, right? Pythagorean theorem, right? We right angle triangle. We sort of know the 3 side lengths. They're all letters, but at least we can still represent it, right? So how can we do Pythagorean theorem on a green triangle?
A squared. No. Yeah, equals to h squared plus 75 minus x squared.
Okay, so we got a squared is equal to 8 squared plus 75 minus x squared. This is supposed to be plus in here. Okay, so this is Pythagorean theorem to the right to the green triangle. Well, I don't like that 75 minus x quantity squared. A binomial quantity squared, I want to expand that out. How do I expand that out again? So I'm going to do this down here. So a squared is equal to h squared plus. How do I expand out a binomial quantity squared? So this is drawing back to like chapter 5, unit 5. 75 minus x.
Why don't we just use the value of x, which we got from the coast?
We could use x and h there, because we actually get those values. But I want to go somewhere with it. So how do we do a binomial common quantity squared? Oh boy.
9,225.
Okay, well let's not get the actual numbers. Even if it was just
The test next Friday, right?
how would you do x minus 1 quantity squared?
X minus
Actually, not even x minus 1. Let's do x minus not 2. X minus 3 quantity squared. Take our first term. You could FOIL it, but what's your shortcut?
Square.
Take the first term,
Square.
square it. Take your last term.
Is it negative 3, not 3?
You're negative 3.
So that's plus 3 squared.
Well, what?
And what's the middle term? So we take the sign times 2 times x times 3. Remember that was your shortcut? Yes?
No,
Jogging your brains a little bit?
I don't remember that at all.
Take the first thing, square it. Take the last thing, square it. It's going to be a positive. Then 2 times, or 2 terms multiplied together. Right? So we want to take that.
Boy, that was nice.
Yes, I think we ran out of batteries. So I want to take that and apply it to this now. Oops. So what's my first term? 75 squared minus 2 times 75 times x.
Do we negative x?
Well, I'm subtracting. So this is my subtracting here. Right? And then plus x squared. Okay? So I just took that, expanded it out. Now I'm going to just rearrange the terms a little bit. So I can get a squared is equal to h squared. I'm just going to move the x squared over. So it's beside the h squared. Okay? So now I'm left with plus 75 squared minus 2 times 75 times x. Okay? So I just shifted the plus x over to beside the h. Why would I want to do that? So that you can visually see this part. I'm going to take my, what's x squared plus h squared? What is that equal to? 60 squared, right? Actually, I wanted to do this. X squared plus h squared is equal to 60 squared. Do I have h squared plus x squared over here? Do I have that over here? What's that equal to?
6 squared.
60 squared. So I'm just going to replace that. So a squared is equal to 60 squared plus 75 squared minus 2 times 75 times x. Okay? So it was a little trick there that, you know what, I got rid of 2 variables because I know the square of both of them adds together gives me 60 squared. Well, over here, I still have another variable x. So over here, what I realize is that I want to take this over here because x is equal to 60 times the closest 64. So now I'm going to plug that back in. So I got 60 squared plus 75 squared minus 2 times 75 times 60 cos of 64. So that's sort of taking what we know about the red triangle and sort of going back to our green triangle, having those equations and doing some substitutions. So in the end, we go off and plug this in. So a squared is equal to 3600. What's 75 squared? I think Jordan said for me already. I don't remember. 5625? And then if I do 2 times 75 times 60 times close to 40, what do I get? I get minus 3945.34. So here a squared is equal to, if I do all that, 5279.66. So how do I get for a? How do I solve for a? Yeah, square root both sides. So a is equal to roughly 72.66. Any questions along those steps? There were quite a few steps.
What does this part say? Like the 4 going down?
Down here?
Yes.
So I get a squared is equal to 60 squared plus 75 squared minus 2 times 75 times, I couldn't fit it on the same line, times 60 times the cos of 64. Because I did was replace x with what was up here. Okay, which was 60 times the cos of 64. So if I give you a question like this, where you got one angle and 2 sides, do you want to do this math all the time? All this algebra? Which is why, Christian, that's a great observation that you made. When we got to over here, we could solve for h, and we could solve for x, and then we could get the value of a. But even doing this all the time is a little bit cumbersome, remembering this. So what I want to do is I want to highlight this part of the equation. So go back to your notes. Right at that line. Or Ryan actually asked me about that. What I'm going to do is I'm going to substitute in the numbers for our letters that we have on our triangle. So we got a squared is equal to, well, what's 60? What does 60 map to? Yeah, 60 maps to little b. Oh man, that's really off.
This guy.
What does 75 map to?
Little c.
Yeah, 75 maps to little c. So that's c squared minus 2 times 75 maps to again. Big C, little c. 60 maps to little b. And cos of, what's 64 map to? What's 64? Yeah, 64 is our big A. So here we have a general equation based on what we're given to solve for that side length. So when you just take your triangle again from scratch, so draw another triangle, label it like this. So this is the exact same triangle that we worked with the question, except now we're just going to use the letters.
Use one for another course.
Okay, so it's just a triangle, standard labeling now, A, B, C, all uppercase on the vertices, lowercase a, b, c for the side lengths. So we call this the cosine law. Okay, so the cosine law is a squared is equal to b squared plus c squared minus 2 times b times c times the cos of a. So which one is very easy to remember, this one or the sine law? Sine law. Which one do you think is easy to work with algebraically and arithmetically? Sorry? Well, I would probably say the sine law, right? We got a lot of squaring there, adding, subtracting, right? So worst case scenario, we'll always, best case scenario, we try to use the sine law. So what Michael did at the beginning, right? Write out the sine law, start plugging in the numbers, and can we use the sine law there? If we can, awesome. If we can't, then we need to use the cosine law. What's the cosine law really saying? Actually, let me give you the other version of it. You can also rework it. So if I drew the vertices, the line from the vertex, other ways, they can be written other ways. So you have b squared is equal to a squared plus c squared minus 2 times ac times the cos of b. Finally, the third version of it, you could like if c squared is equal to a squared plus b squared minus 2 times ab times the cos of c. Okay, it's really one equation. Now let me try to summarize what it means. If you know the angle and the two sides beside the angle, to figure out the third side, you just take your two sides that you know, you square them, you add them together. What's that sound like? Square them, add them together. What other formula does that sound like? Pythagorean theorem, right? A squared is equal to b squared plus c squared. Same thing. Square your two sides, add them together. The only difference here, you subtract 2 times both your side lengths times the cos of your angle. And that's really your equation. That's it all three ways. Okay, any questions on that? No? Let's try an example. So here we want to solve for b. First of all, first thing check, can I do the sine law? No, I'm looking at it, I got two sides, I know the angle in between, I can't do the sine law. So how do I get b? Cosine law, so how do I do it for b? Thank you, Amy, louder. You can memorize it by now? Right? Square up both sides that we know, add them together, minus 2 times each of our sides times the cos of b. That's what you get for b squared. So here, does it matter which one I label A, B? A and C? No. So I'll say this is A, this is C. So by default, that make this angle big C, this angle big A, even though we're not solving for it. Just nice to label my triangle completely. So this is big B. So B squared is equal to, well, the value of A is 10. Value of C is 15. Minus 2 times 10 times 15 times the cos of B, which is 66. So B squared is equal to 100 plus 15 squared is 225. Minus, question, Michael?
Yeah, for when you're doing like the 2 times 10 times 15, would you also do the times cos?
Yeah, so I just do everything all at once. So it's basically 300 times the cos of 66. What is that?
122.02.
122.02. So b squared is equal to 325 minus 122, which gives me 202.98.
Would you subtract like 2 times 10 times 15?
Sorry, what did you say? Yeah.
Where do you subtract like 2 AC?
Where did I subtract 2ac? Right here. So there's 2, there's a, there's c, and there's cos of b. And so Michael put that in his calculator. He said all that was equal to 122.02. Yeah. Great. Yeah. Answer. Okay. So doing all that, I get 202.98. So what's the square root of that? That's going to get b. So what's b? Sorry? 14.25? So therefore b is equal to 14.25 centimeters. Okay? This is a matter of drawing a triangle and just plugging in numbers afterwards. Any questions?
To try to solve the problem by yourself, pause the video now.
Because hopefully you have a triangle that looks something like that. RST, angle of R is 72, basically the two side lengths beside it is 9 and 12. So can we do the sine law?
No.
No. What's the only thing that we're trying to solve right now?
R.
Yeah, we can only solve for this side length over here, which I'll do in blue. We can only solve for R. Okay? So how can we solve for R?
Cos.
What's that formula?
Okay, ready? Are you
Okay, let's give Christian a shot.
Okay. R squared.
So
Lowercase r.
R squared
Equals to t squared plus s squared.
So all we do is just taking our other two sides, squaring them, add together. So it almost looks like the Pythagorean theorem, right? So up here, we don't need to identify hypotenuse or anything. The only thing that we need is the side that's unknown is r squared.
Okay, minus 2 ts.
Yeah. So
And
2
then-
times the two side lengths.
Yeah. And then cos r. Options r.
Excellent. So we just go in. That's why this section to me is so dry. But honestly, it's so easy for you to get marks. Because it's just, here's the equation, here's the triangle, can we plug in the values for the variables and then use the calculator to get the answer, right? So r squared is equal to t is 9 plus s is 12 squared, so it's 12 squared minus 2 times 9 times 12 times the cos. That's the cos of r, which is 72. So r squared is 81 plus 144. And what's the mess on the right there? 2 times 9 times 12 times cos of 72?
It's 66.75.
66.75.
66.74.
It's 5.
Ballpark. Close enough. So what happens when we add those three numbers together? 158.25. So the square root of that? So R is equal to 12.58 meters. Okay, so we're good for R. So basically same as last question. Now how do we solve for the rest of the triangle? Yeah.
This is a question.
So we just go back to the sine law because now what's our magic ratio? R over sine of R, which is 12.58 over sine of 72.
That's two decimals. 2 decis is
So here's a note. So write this note down. Michael, pay these please. It's awesome. Takes two to tango. Ever heard that phrase before?
Those two. I'm the good one in this.
Apparently it's three tangling. So if you can't use the sine law to start, write this nice note down. If you can't use the sine law to start, then use the cosine law first. And then use the sine law afterwards to finish solving for the triangle.
good tangent law.
But
Just these two.
we could discover it if you want. We try to discover it. I haven't heard of a tango law. Except I'm going to call it the Tam law.
The Tam law.
When I discovered it. Okay, so here we want to figure out angles S and T. So which version of the sine law am I going to probably use? Yeah, so we want the angle on top. Okay? But you know what? I saw too many problems when the sine was on the bottom algebraically that I'm going to do one with that. So let's solve for angle S. So we got R over sine of R. So you put an S over sine of S. So we got 12.58 over sine of 72. So here we know angle side S, which is 12, but we don't know sine of S. Okay?
So why do we flip it?
So you can flip it, but again, we look at just doing the cross multiply so that we get rid of our denominators, right? Because here our variable is on the denominator, it's on the numerator. I've seen, I don't know where you guys learned this or missed it. A lot of kids multiply both sides by 12. They multiply both sides by 12 and then they're just left with sine of S on the right hand side. Multiplying by 12 on the right hand side just gives you 12 times 12 over sine of S. It doesn't get rid of 12. It doesn't bring the sine S from the denominator to the numerator. So what we do is we're just going to cross multiply. So we got 12.58 times the sine of S. So we cross multiply. So that's equal to 12 times the sine of 72. So sine of S is equal to 12 times the sine of 72 over 12.58. So you're going to work up here. So it's 12 times the sine of 72 divided by 12.58. So we take this 12 times the sine of 72 divided by 12.58. What's the answer there? You guys have the calculators. Michael.
Okay, I have a question. The second step, where it's like 12.58 over sin 72.
Right?
And then
Is equal to 12 over sine of S.
Oh, the 12's from now. Okay,
12 is
never mind.
from the little s. 0.91. So that's the sine of S. In order to get S, we need to do what?
Get that sine of S.
We need to do the inverse sine, right? So we get S is equal to the inverse sine of 0.91, and that is equal to 65.12. So S is equal to 65.12. And how we get angle T? I would probably do the sine law again, to be honest. But I'm going to subtract it because I'm like Christian, I never make mistakes.
Yeah, I know that.
So 180 minus 75, 65. So it's 180 minus 137, which is 53. So 52.88. If anything like Christian, I probably got that wrong.
Isn't it or 42?
See, there you go.
That was
That is a good one. April Fool's.
Okay, so that's how you solve for the triangle. Any questions on this? Okay, so solving the triangle, you have to apply both laws.